This presentation explores how Rural Observatory and digital twin technologies can strengthen rural infrastructure, public services, disaster preparedness, and food security. By turning spatial data into intelligence, governments can make faster, smarter, and more equitable decisions for rural communities. Digital twin analysis gives agencies a real-time digital view of rural infrastructure, from roads and water pipes to power lines and public facilities. By combining sensor data, maps, and predictive tools, potential failures can be detected before they happen, leading to more reliable services and better planning in remote areas. Rural infrastructure often suffers from limited visibility, slow maintenance cycles, and fragmented data across agencies. Digital twin analysis addresses this by integrating real-time insights and predictive tools, transforming infrastructure management from reactive responses into proactive, data-driven planning. This section focuses on how digital twin analysis supports infrastructure project planning, starting with critical utilities such as water and electricity. Water infrastructure is a core foundation of rural development. Digital twin analysis helps agencies visualize water systems holistically, from source to distribution, enabling better planning, monitoring, and long-term sustainability. By simulating road networks and terrain, rural observatories can optimize access routes to essential public facilities like schools. This ensures safer, faster travel for rural communities and supports equitable service delivery. Digital twin mapping shows public facilities such as hotels, petrol stations, and restaurants alongside population data. This allows authorities to align tourism development and infrastructure investment with real demand and accessibility. Digital twin analysis identifies the most efficient routes to dams by simulating terrain and flow paths. This reduces planning delays, optimizes resource allocation, and strengthens rural water supply strategies. By visualizing how water moves across rural landscapes, agencies can plan infrastructure that aligns with terrain and community needs. This improves water access and supports sustainable rural development. Combining land use data with dam proximity allows agencies to identify which rural areas need water infrastructure investment most urgently. This ensures development is targeted, efficient, and responsive. Monitoring rainfall and river levels helps agencies understand seasonal patterns and flood risks. This supports smarter decisions on where to build reservoirs, piping systems, and flood defenses. Beyond water, reliable electricity is essential for rural growth. Digital twin analysis supports power infrastructure planning by integrating terrain, demand, and access data. Digital twin technology helps agencies identify optimal locations for power plants and substations. Accurate geospatial data reduces planning errors and improves energy access in underserved areas. By simulating routes between Keningau and the Tenham Pangi hydropower plant, planners can assess terrain challenges early, improving cost estimates, reducing risks, and ensuring long-term grid reliability. 3D digital twin mapping allows agencies to assess how close rural communities are to hospitals, schools, and fire stations. This supports smarter infrastructure upgrades and improves overall community welfare. Energy demand mapping highlights industrial zones with limited residential coverage. This enables agencies to prioritize electricity projects where economic impact is highest. Observatory tools provide a national view of power plants by state and fuel type. In Sabah, understanding the mix of hydro, solar, gas, and oil supports resilient and locally tailored energy planning. This section focuses on how digital twin intelligence supports inclusive and sustainable rural development. Digital twin analysis enables real-time monitoring of rural development projects like Desa Lestari. Agencies can track infrastructure progress, funding allocation, and community impact transparently. Mapping travel routes between rural communities and medical facilities helps agencies plan healthcare access and emergency response more effectively. Analysis shows Desa Lestari is approximately 5 km from the nearest hospital, with limited clinic coverage. This highlights the need for additional healthcare infrastructure and better emergency planning. Digital twin mapping connects farms to markets, reducing spoilage and improving logistics. This supports agricultural investment and strengthens rural income opportunities. Land use visualization shows how rural areas are distributed across forests, agriculture, water bodies, and settlements. This supports more sustainable and targeted development decisions. This section focuses on how digital twin intelligence strengthens disaster preparedness and risk reduction. By combining rainfall, river flow, and terrain data, agencies can predict flood-prone zones and plan early warnings. This reduces damage to homes, crops, and livelihoods. Digital twin simulations compare evacuation routes from flood-prone areas to shelters, ensuring faster and safer emergency response. Real-time rainfall tracking enables early detection of flood risks, allowing communities and agencies to act before conditions worsen. Mapping clinics and hospitals across districts helps agencies identify medical access gaps and deploy resources more effectively during disasters. This section explores how digital twin analysis supports coastal and fisheries-based rural economies. Digital twin and OSINT data enable real-time monitoring of ports, jetties, and vessel movement, supporting sustainable fisheries and coastal security. 3D visualization of Chendaring Port helps agencies assess logistics capacity, improving cold storage planning, distribution efficiency, and fisher income. Mapping fastest routes from ports to police stations improves enforcement, safety, and emergency response for rural fisheries. This section summarizes the real-world impact of Rural Observatory intelligence. Digital twin analysis enables faster response, smarter planning, and coordinated service delivery. This builds safer, more resilient rural communities. This section highlights food security as a pillar of rural resilience. By integrating production, market access, prices, and risk data through the Rural Observatory, agencies gain a clear view to plan better and respond faster. Food security depends on production, distribution, and access. The Food Security Dashboard integrates these elements across districts to provide a holistic view. The self-sufficiency ratio shows that several commodities still depend on external supply, highlighting structural vulnerabilities in food production. Some districts have large cultivated areas but low sales value, indicating productivity gaps among small-scale farmers. Market availability ratios reveal uneven food distribution. Strong production does not always translate into strong local availability. Food prices vary by district and market type, reflecting transport costs, distribution efficiency, and market structure. Frequent price fluctuations increase food insecurity risks, especially for low-income households with limited choices. Rural areas rely on small retail outlets with limited options, leading to higher prices and reduced food diversity. By integrating production, prices, markets, and risks, the Rural Observatory enables scenario-based food security planning. This integrated analysis helps policymakers identify vulnerabilities and respond with targeted interventions. Floods disrupt food production and supply chains, increasing dependence on external sources and exposing systemic risks. Declining domestic production widens the supply-demand gap, increasing reliance on imports. Rural and low-income households are most affected by supply disruptions and rising prices. Distribution constraints and production shocks cause uneven price impacts between urban and rural markets. Diversifying production across states reduces concentrated risks and strengthens national food resilience. Buffer stocks and flexible trade agreements stabilize food supply during disasters and market shocks. Climate-adaptive farming, resilient crops, and modern irrigation increase productivity and protect food systems from future shocks. Thank you. Through Rural Observatory and digital twin intelligence, we can build stronger infrastructure, safer communities, and resilient food systems for the future.